Welcome to this pre-recorded lecture. As you can see, I'm actually at home in my home office, under the roof here, where I'm usually working these days, and I've been here for over a year, and I'm sure most of you have as well. And of course, this is not what I intended when I agreed to give a keynote lecture, where I'm very proud to be able to do this. So thank you for having me, albeit only in a digital format. It so happens that actually speaks to what I want to talk about. But before I even get to what I want to talk about, I want to go back a little bit in time and show you a little bit about my very first paper. This is my very first paper. I was a very young doctoral student, and I had some work from my master thesis, I believe, and I submitted that to a workshop with one of the main conferences that are about information systems engineering, software development, systems engineering, systems analysis and design. And I was very proud because I was accepted to go there and present in a workshop. And in these days, what I wanted to show you, you had a chapter in a book. There was no PDF, there was no digital file, there was no DOI at that time. You actually had a book, and I have it somewhere. And I had to look it up. You can see me here that I took a picture of it so I can show it to you. Two things. Number one, research was different back then, wasn't it? We wrote papers that were actually papers, and they got published in books and proceedings and so forth. And the other thing I wanted to highlight here, at that time, around 15 years or 16 years by now, I looked into conceptual modeling. And that's what I want to talk to you about today, conceptual modeling, and how the times have changed from back then, when we wrote papers that were published in books, to now that we write PDFs that get put on a web page, and where I'm delivering this keynote to you from home with a pre-recorded digital stream that I had taken many days to set up, in fact. So the question that I want to ponder today is whether the world that has changed, as I will try to show to you, whether it really has changed a lot, and whether we as researchers that are looking at systems analysis, system specification, software design, software development, are really up to speed with what's going on in the real world. And as a keynote, of course you can imagine that my answer to this question is, no, we're not, and we need to change, and we need to get better, and so forth, all right? So I want to provoke you a little bit. So I mentioned I've been looking at this area of conceptual modeling, which is a part of this entire stream that looks into systems analysis and design and development for a very long time. And in case you're not familiar with this, what I'm referring to are diagrams that look a little bit like this here. So conceptual models are usually diagrams that we use to specify or document what a domain is that we want to have an information system support. So that could be, for example, we want to document how invoice processing works in our organization. So we can draw an activity diagram, a process model that captures that. Or we could take a state chart diagram or a class diagram to explain what the data structure is that a particular information system supports, right? All of these are conceptual models, and they're typically, as you can see here, graphical. They contain certain semantics, arrows, and boxes that all mean certain things. And we typically capture a particular domain, say banking, finance, invoice processing, a library, whatever it may be, or they capture what a particular system is that we're analyzing. Yeah. So the graphical representations of real-world domains and information systems. And we use them a lot for specifying, analyzing, communicating, validating requirements with a whole bunch of stakeholders. They could be domain experts, they could be analysts, developers, designers, end users, project managers, and so forth. That's the main purpose of why we model the world around us. And it has always been an interest to people in information systems and people in computer science, particularly in software engineering fields, everyone that's concerned with building, analyzing, and improving systems. Yeah? And in information systems, that's the discipline that I am. It's been a core topic since the beginning of the field. So for the past 40, 50 years that we have this field, it's been a deep core because it goes to the heart of what is actually an information system. But the funny thing to me always is it's core, but it's niche. Yeah, so it is fundamentally a topic of interest to information systems, but then again, it never attracted a large community of people to work on this. So I think that today I'm speaking to a community that is interested in this topic, but if I go to broader conferences about the field, I'm typically, sort of like a niche guy. And a niche and a boundary type of guy because this is a topic that spans fields. So that's what I want to talk about today. And I've brought a graph here because at some stage we had a look at, okay, how much do we publish on this topic? Yeah, so this is not over the last 50 years or so, but you can see here, this is a graph on conceptual modeling papers in our scientific databases from about, late 80s to about 2016 when we ran this analysis. And you can see, there's a steady incline, and, it's actually going well, so to speak. We publish a lot. And you can do similar types of analysis, and we did at some stage on, where is all this research published? Is it in niche journals? Is it in the top journals? And, where does this work appear? And you can show you, look, there is a lot of publications, and there's more publications than ever before on this topic. Yeah, so one could say, hey, conceptual modeling, that's a topic that's of interest, it's persistent, and there's more and more good research coming out. At the same time, however, if you're in this field, a lot of people say, well, our community is not in a good place. Our field might be dying. Yeah, so I brought two quotes here. Yeah, so one of them is from two very esteemed senior colleagues, Yair Wand and Juan Weber, that wrote a reflection article 4 years ago. And they said, well, that niche topic is actually even less of a niche now because it's not as sexy, basically, is what they're saying. It's not as sexy as new stuff. It's not as sexy as social media. It's not as sexy as robotics, as artificial intelligence, etc. And I myself, a couple of years ago, when I was talking at a conference, I said pretty much the same thing. I said, oh, look, we got to have a look at whether what we're doing in conceptual modeling research, whether that's still relevant, still valid, and still has utility, has still some benefit to the world that we know now. So otherwise we run the danger of doing things that are really long in the past. Yeah. So that is a tension. That's a dilemma that I'm trying to present to you here, right? So we have more and more publications than ever. At the same time, we have voices that come out and say, maybe, it's time to put this aside. And this is not just a debate per se for the sake of debating. This is a real problem. Imagine you have a doctoral student that comes to you and he wants to study a particular field. Well, what do you tell him or her? Will you tell her, you should really do research in this conceptual modeling area because, there's some big problems to be solved and will have a lot of benefits, a lot of impact, you can make the world a better place? Or will you tell them, stay away from that? That topic is done and dusted. We've solved it and we've moved on, it's no longer relevant. What is the answer to this question? So I actually asked myself the same question when I had a young student come in and said, I want to work with you. I don't want to work on conceptual modeling. Do you think that's a good idea, Jan? And I said, I don't really know. Yeah, so that's not just a topic for young scholars, it's also a topic for sort of the senior people in the field, the thought leaders and so forth. So just one example from this, in the email distribution list within that community, there was a post a couple of years ago who said, oh look guys, what can we do to make our field, conceptual modeling, stay relevant in this big data world, cybersecurity, AI, machine learning, this new world that we're in. And then I posted a few responses here. You can see, oh look, we just need to promote more ideas. We just gotta show people how sexy it is, and then we get more fresh people to come in and work with us. That we attract more young scholars. And others people have basically given up and said, oh look, we all think it's important, but no one else does. So that's just how it is. All right. So what I'm trying to show you is that even within the community that has been doing this research for a long time, people feel unsure about the place. They themselves don't know what to do. Yeah. So the question that I wanted to explore a little bit, or that I have been exploring over the last couple of years, is, okay, so what happened and when did all of this happen, and what can we do about it, of course. And we all know what happened, of course. The digital age has begun with a whole bunch of developments that have changed what the reality around us is and what the role of technology and systems is within it, right? And a lot of this stuff may not necessarily be new to you, but I'm gonna go through it pretty quickly so we get a feel for what the implications might be. Yeah. So the first question is, okay, the digital age has begun. Well, when has it begun? So this is another graph that I did. It's not highly scientific, but what I did is I had a look at papers that were published in IS conferences and had a look at the frequency of the occurrence of the term digital. Yeah, so digital something rather in all the articles. And you can see here that there is this spike here in 2008 around, where you can say, hang on, well, this is really when the term digital really entered our vocabulary, and it has been, basically been in high frequency ever since. Yeah. So around that time, and that sort of gels with my own observations, sort of my own view on this matter, when that digital age really has started taking off and having a profound impact on global society. Yeah, and you all know this. So this is a graph that I use a lot an image that I use a lot in my teaching to MBA students, and it shows the connections on Facebook around 2008 or 2009. Yeah, so it shows people that were connected via a social networking platform, Facebook, around 2008, 2009. So if you think back around that time, Facebook had about 500 million maybe users that were connected at any given point in time, and it connected the entire planet. Obviously not evenly. You can see here that Europe, some part of Asia, Australia, and of course the United States were more connected than say Russia, Africa, South America, and so forth. But it was still a pretty unprecedented scale and volume of connections. 500 million people doesn't sound like a lot these days. Back then, obviously, it was unprecedented scale. And it led to business really worrying about it. So Ralph Norris was then the CEO of Commonwealth Bank Australia, which is a major Australian bank. And he said, I'm not worried about ANZ. I'm not worried about Chase or other banks. I'm really worried about Facebook. Yeah, because now that people can start connecting with everybody else on the planet, why do they need an institution like a bank anymore? They just need to connect with someone that has money and gives them some of it. Yeah, and that was really one of the starting points, and it has led to a whole lot of what the mainstream media is called digital disruptions that have started since then, right? So not only do we have Facebook that started competing with banks, we have cases like taxi versus Uber, Seek versus LinkedIn, hotel versus Airbnb, banks versus Facebook, Airbnb versus restaurants, MOOCs against education and universities, of course, that's another one of these things. And the common theme around this is really that we had digital players entering a typical analog world and really started, disrupting or transforming, definitely changing the landscape for a lot of these things. Another thing, of course, that happened around that time, if you think back, around 2007, we had the first true smartphone hitting the market. I was in New York at that time, and I remember the people that literally camped outside of the Apple store waiting for the iPhone 1 to arrive. Yeah? So if you think about what that means, it means all of a sudden that true ubiquitous computing was achieved. Everyone had a pretty powerful computer in their pocket, connected through, back then, I guess, 2G or 3G wireless technology. And it really started happening that people had a technology that was not just a personal computer or a laptop in their office, they had it every time, everywhere they went. So it started blurring the boundaries of business life and private life, of home and work, of leisure, and the office. And we all know this now, and it seems pretty normal these days. Back then, of course, it was a major shift in what that happened, right? And this goes to show what happened because of the rise of platforms such as social networking technologies like Facebook, coupled with the availability of these mobile computing technologies like the iPhone and then similar types of mobile phones, smart devices, tablets, and so forth, right? So it's not uncommon to hit billions of users these days on some of these platforms. But you can see here again that a lot of that started around this 2006, 7, 8, 9, 10 sphere, and it's really been skyrocketing ever since. Yeah. Another thing that happened around this time is that in 2008 was a so-called inflection point where the first time ever we had more digital things being connected on the planet than we had people on the planet. You see here the blue line, that's the world population. It's been increasing. We're sitting about 8 billion people these days. But in 2008, for the first time, we had more smart objects, technology, devices that were connected through internet. For the first time, we hit the same population as human beings, and it's been skyrocketing ever since. So I think in 2016, we had 20 billion smart objects connected, and these are only the ones that are connected through the internet. There are about, I think, 200 billion technological objects, so objects with digital technology on them, but not all of them were actually connected online, so to speak, all the time, and that's been going crazy ever since. So we have more things than people on the internet, so to speak. Yeah. Another thing that happened, of course, and you all know this by now, that we have an incredible leapfrog or incredible advancement in artificial intelligence technology. And I only brought one chart here that shows funding. So investment in these types of technologies. And you can see again how that over the last 10 years has grown as an exponential pace. Not all of that is maybe all that intelligent. Some of that might just be stupid, but just the sheer fact that you have so much more money pouring in, that means there is just more advancement just because there's more resources being dedicated and invested at these tasks. So we have more things, we have more connected people, we have more connected things, and the things are getting smarter all the time, whether you like it or not, or whether that is a form of intelligence that is like human intelligence or some other form of non-intelligence. So isn't really my point. My point is more that we have more digital things, more digital objects, and the digital objects more and more can do certain things, and they can do more than they ever could. And a lot of that has happened over the last 10 or so years. And of course, a byproduct of all of that is, of course, that we have more and more data. Yeah, more and more data, whether it be generated by humans or by algorithms or by AI or by other types of things or objects. The amount of data that is being produced and consumed and available and being sort of curated all the time is just growing all the time. And that's it. None of that is necessarily new, but all of that characterizes this digital age that started about 10, 15 years ago, and that has led to the situation where we're in, that we all come to realize and experience ourselves in our daily lives. I mean, if you look at what we're doing right now, I'm here in my home office due to the ongoing pandemic, of course, but it still allows me to actually speak to you in a much more sophisticated digital way than was ever possible. Yeah, so when I was a student, I still had professors that had overhead projectors, and they were writing stuff on the overhead projector, and I was sitting there with my notepad and I wrote stuff down. Yeah, and of course now the situation looks a lot different. That's why I showed you this picture in the beginning of my very first paper that was actually a book chapter. Yeah. So a couple of things that characterize this digital age. We have smart devices. We have a higher level of connectivity between people, and of course things that are being connected and speak to one another and interact through internet technology. And the things, the objects, because of advances and sort of investment in artificial intelligence, are becoming smarter, however you construe that term, and they become more agential. So they can do more things. Whether it's meaningful or good or bad, doesn't matter, but they can do more things than they ever could before. And of course, we have more data. So that's the situation, that's the reality that we have. And that's the reality that, of course, that information systems researchers need to go out and study and try to understand and improve and so forth. So that's really our phenomena that are out there in the reality that we are concerned with. Yeah. Now, sharp contrast, that's reality right now, and this is conceptual modeling. This is our theory, so to speak. Yeah. So this is a framework that is probably the most famous paper on conceptual modeling that's out there. It was a commentary around 20 years old now by Ian and Ron Weber. I mentioned them earlier. They wrote a commentary 20 years ago, and that basically gave us a framework on how to think about conceptual modeling. They said, well, look, we have grammars, like UML, BPMN, and others, and we use them following a particular method to create these scripts. And the scripts convey certain information. Yeah, so we can have a class diagram, or we can have a use case diagram that shows us what the use cases are for a particular system. We can create process models to understand what business process and routines organizations are going through. All of that happens, of course, in some sort of context where conceptual models are being produced and consumed and used and so forth, right? So this is really the language, the vocabulary with which researchers that are interested in conceptual modeling have looked at the world and all the phenomena and the problems and developments that are happening out there. So this framing, this vocabulary, this framework here is now 20 years old, and I've just shown you what the reality is and how that has changed over the past 20 years. And the provocation that I'm putting out here is that the world has changed, but our research has not. So we're still living in an age that is characterized by what One and Weber had when they wrote this article 20 years ago. So in the sort of 90s and so forth. Yeah, and then, it came out in 2002, so it must have been written around the year 2000. And if you think back, if you're old enough, the world was a lot different back then. Yeah. Yeah. So what are some of the things that happened in the meantime? Well, of course, since then we had in systems analysis and design, we have movements like the agile development, or more recently DevOps, and they have fundamentally changed how we analyze and design and operate information systems. Yeah, so systems analysis and design has changed a lot since the late 1990s, the early 2000s. And for example, in DevOps and agile development, on the surface, there's no place for UML or ER diagrams or functional diagrams and so forth. We have, of course, also other types of technology developments that are relevant to systems analysis and design. For example, conceptual modeling was for a long time a lot about relational databases. With the most famous example of the entity relationship diagram that allowed analysts to specify in conceptual form what a database should capture and how it should be constructed and how you could query it and so forth. Well, we have no SQL databases. We have very different types of databases. We have different types of analytics and data learning algorithms that really challenge this idea of a relational database from the 70s. Right? So that happened as well. We have technologies and data that doesn't only sit within the database that underlies an SAP system or a Microsoft Access. We have data and we have technologies in all sorts of things these days. I have, a computer on my watch here. I have a computer on my cell phone. I have a mini computer in my toothbrush. Yeah, in the bathroom. So in everyday artifacts, in economic goods, and of course in very complex systems as well. Drones, self-driving cars, God knows what we have. So we have information systems, database structures, they look very different. They're not just software artifacts that run on a laptop or on a computer or on a mainframe. It could be things that has to run on your armband, your wristband. Yeah, so that is very different as well. In the words of conceptual modelers, we would say, look, information systems do not only have a deep structure where the semantics are important of the data that is captured in some sort of database. The information systems that sit in artifacts, they have a physical structure. My wristband, my watch here is very different from a Fitbit, is very different from a Nike Plus shoe, is very different from a smartphone, very different from a tablet and so forth. So the physical appearance and structure of a thing all of a sudden has more meaning because it's different, it can vary. It's not just a piece of software that runs on a computer. And of course we have things that increasingly what happens in a digital reality, in a digital space, influences what happens in the physical and the social reality that we know. And we've seen this a lot, yeah. So over recent years we've seen how conversations that happen on Twitter change entire political processes in a country. What people tweet and what people say on these platforms has a profound impact on what people really do in reality. That's very different from in the old days where we had to look at, okay, what's the real domain? What's happening here in invoice processing in my organization? How can I model that to have a system support that? Well, now a lot of the things are different. What happens in the digital space happens first Yeah, and Richard Baskerville and others called this digital first, and then it impacts physical reality. Yeah, and we also have other movements. We have more collective action movements. We have crowdsourcing, citizen science, and so forth. We have a lot more things where everyday people, non-specialist users, start developing, using, and operating information systems. Information systems are no longer a matter of professionals alone. My son is building his Lego kits with an online instruction plan, an interactive plan, with an iPad, and he's 5. Yeah, so, and he can handle it too, probably better than I can. So all of that is happening as well, right? So just to give you some examples of this, to explain this notion of a digital first. Now we have the situation that we have sometimes digital models existing prior to real world objects. Yeah, and I've noticed it's the first time around 2012 in Australia when I was working with Woolworth, and they created what they call the dark store. A dark store was a supermarket. Woolworth is a supermarket chain like Costco, Tesco, Walmart, Rewe, Aldi, these sorts of things. And they were operating a store that they had to design for only their online deliveries, meaning that they had a shopping app where people could shop online and had their vegetables and produce sent home to them. And what happened is that this model grew so prominent that they needed have a particular store where they can actually fulfill all these online deliveries. And they had no idea how to design it. They knew how to build a supermarket where they could entice people to shop for good vegetables and get the Snickers at the end before they pay. But all of that was irrelevant in a dark store where they try to complete online orders. Yeah, and this has taken over. So Walmart, this is an article from only last year. Now Walmart is designing its stores only based on what they know from how customers shop online. So what happens in the digital space exists first. Yeah. Another example here is from 3D printing. Very interesting studies around that we create digital models of things first. And this example here are actually whistles that you can create, customize, innovate, change, copy, and so forth before you've produced a single thing. We also have other examples. For example, this is a study that we've done with video game producers, where a lot of the elements of a game are not even designed by people anymore. We have algorithms designing parts of video games and generating insights and for new products and new features and sort of new missions and new things you can do in a video game without human impact. Yeah, so we have algorithmic product design, and this is obviously happening in a piece of software. But you can also there's also examples where people do this with real physical artifacts, like pizzas. Yeah, so this is a project from MIT students where they are creating artificial intelligence to create and come up with the best tasting pizza that you've ever tasted. Yeah, and where they create a conceptual model of the perfect toppings for pizzas based on data they've available from social networks like taste.com and nutritional databases, and they combine it with the machine learning algorithms, and then they tell the chef what to cook, basically. Yeah, coming up with toppings in combinations that you probably wouldn't have come up with yourself. Blueberry, spinach, and feta is not what I usually put on my pizzas. Yeah, so the argument that I'm still trying to make here is that there's things happening in the real world that I think are deeply and fundamentally connected to conceptual modeling, but it's not at all what we're studying. It's not at all what conceptual modeling research is doing. And at some stage, we wanted to substantiate, I wanted to prove that argument. So we engaged in a very broad review of all conceptual modeling papers over the last 15 or so years. And we had a look at, what is it that people are actually publishing? Yeah, what is it that they're studying? And what they're studying is still the things that Wand and Weber basically told them to study in 2002. They studied grammars, UML, most often entity relationship diagrams, but also Petri nets, business process modeling notation, flowcharts, data function diagrams, and so forth. Yeah. So they studied, most of them studied grammars, they studied methods, they came up with better methods for using these grammars, so how to construct a perfect use case diagram and so forth. Yeah. So this is really what the conceptual modeling research community has done. They still studied how to make UML better and how you can use UML very effectively. Yeah. And the most popular research topic were, and you've probably seen a lot of them, that a lot of studies took two scripts or two models of the same thing, and one was created by, let's say, UML class diagrams, the other one was, let's say, an ER diagram, and they had a look which of these models people understood better, where people could learn more facts about the real world domain that was being modeled at the time, right? So I can give you a model of an invoice processing process, and I can give you a slightly different model at the same time, and you can see where can you answer more questions about invoice processing if I give you these models. And I know this research went very well because, to be very frank, I've done a lot of that research myself as well. Yeah. So a lot of the main dependent variable, if you want to put it this way, the main dependent variable was what people call domain understanding. If I give people a conceptual modeling of a domain, how much do they understand about that domain afterwards? If you give you an ER diagram, do you know more about the domain than if I give you a UML diagram and so forth? That's really the main dependent variable. The main method where either we constructed new grammars, new scripts, new methods, or we evaluated them in sort of lab experiments where we took, two groups of students, one got model A, the other one's got model B, and they looked at this. Yeah, so that's really what we've been doing the last 20, 30 years. Most of the papers are of that sort. Now, I'm not saying all of them are. There's a lot of interesting stuff happening on, but by and large, this is what the conceptual modeling research community has produced. And we think this really has led to a schism, a gap between how the world has evolved and what we're still doing in research. Yeah, so I told you that we have more and more objects that blur a deep physical and surface structure. So we have more and more information systems that reside in things, not just in software. We have these types of systems, technology, and objects that are developed and used in everyday life, not just by analysts and designers in an IT department. We have more and more digital objects that have autonomous agency, that can do things, that can interact by themselves with others. And we have more and more digital first type of objects that are in existence before a physical or real counterpart is in reality. Yeah. And what do we have in conceptual modeling? Well, we only still focus on the database structure. We still focus on what's called the deep structure meaning of, what are we conveying about the domain here in our models? We still think that conceptual modelings are developed and used only in organizations, by IT departments, used by analysts and designers. We still think that it's only professional analysts, people, that use conceptual models. And we still think that the purpose is that we need to represent a piece of physical reality so we can put it in the database of some system. And as you can see, that is more and more unfitting, unaligned with what is happening out there. Yeah. So what I'm saying here is we need a new path. We need to think about conceptual modeling differently. Yeah. I'm not saying that this vocabulary, this framework hasn't been very useful. It's been incredibly useful. And it still is useful, but it needs to do more. We need to relax some of the assumptions. We need to expand it necessarily. So what I and a couple of colleagues of mine have done, we've taken this framework and we updated it by relaxing some of the binding assumptions of it and just expanding it a little bit. And this is what it now looks like. You can still see we still have methods and grammars and script and context here. So we're talking about the same vocabulary here. We have a couple of more things here. We have a distinction between physical reality and digital reality. We have an agent, someone that does something here in as well, right? So you can see, hopefully you can see that it bears resemblance. It's a continuation and extension of how we think about conceptual modeling. It's not an alternative, it's just an update, if you want. And I'm going to take you through what we mean by this. So this old way of looking at conceptual modeling has certain assumptions that I've tried to present you with some challenges. So number one, that scripts are about representing physical reality in a model of a script that's supposed to be implemented in information systems. Yeah. So the challenge that we have in the day and age that we live in is that we have information system residing in things that not only represent reality, but also create, shape, influence, govern what's going on in the real world. Yeah. We also have that old assumption that scripts are really only about the deep semantics that are to be conveyed or stored in a database. But we now have more digital objects that not only have that deep structure, the semantics, but also have physical elements and surface elements. So we need to take into account what that object looks like, how we interface with it, and so forth. The third assumption is that we have scripts that are being produced and consumed by humans only. But of course, we have more and more digital objects that have agency by themselves. So we can have algorithms that can produce models. And of course, we can have algorithms and other technologies that need to consume some of these models and the information they convey. And finally, we traditionally think that conceptual modeling happens within organizations. But of course, they also happen and have a relevance on our lives outside of work, also in the non-work settings of everyday life. Yeah. So what we've done is we said, well, we got to relax all these traditional assumptions so that we incorporate them and other parts. So that scripts not only represent physical reality, but also a digital reality, as well as the places where these two realities meet. Scripts, of course, still represent the deep structure of an information system, the semantics of the data in its database. But we also need to consider how these semantics might be coupled to elements of the physical structure of a digital object or the surface structure. I'm going to give you an example in a minute. Scripts are, of course, still produced and consumed by human agents, but also by digital agents, which means that we need to think more about who actually is the producer here of these scripts and who is the consumer of these scripts. Are we having a human that builds a script for an algorithm, or do we have an algorithm that builds a script for a human, or an algorithm that wants to talk to another algorithm? And of course, conceptual modeling occurs both inside and outside of organizational work. And this is really what our new framework tries to convey. So that we have agents that could be digital or human that are producing or consuming scripts that are generated with a grammar and a particular method, but the scripts are really in a place where they can translate aspects of physical reality into a digital model, or they can take a digital model and make it fit so that we can execute it within physical reality. And all of this happens within the context where we have situations where we have both physical and digital objects and events. We have objects where surface, deep, and physical structures are coupled, and we just have blurred boundaries between what happens at work, at home, in the physical and the social and the digital space. Yeah. So this is really the framing where conceptual modeling occurs, and where now, with this type of viewing it, we have a lot more functions, a lot more purposes of conceptual models. Let me show you some of them. Yeah. So these are the formal definitions. I'm not going to go through them here because there are in the paper if you want to read it. It's open access. Where we paid a lot of money to make it open access so that everyone can refer to it and think about it. Yeah. So thinking about conceptual modeling in this new way triggers 4 key new changes. Number 1, it puts the emphasis away from the grammar to the script. Now we got to think about it a little bit. So in the old days, we were mostly concerned with the grammar that produced the script. That could be the ERD grammar, it could be UML, it could be BMN, etc. But a lot of the research was really focused on making the grammar better, making it more expressive, making it clearer, making it more complete, and so forth. We need to realize that conceptual models of some reality can be grammatical in the traditional sense, but they can also be ungrammatical. People use all sorts of scripts to model the world around them. Yeah, I'm showing two examples here. One is a report in the New York Times that was about the connections between the Trump campaign and the Russians. There was a thing during the US election campaign for a while where they try to describe, okay, what are possible connections, direct and indirect, between certain people and certain events, etc. That's exactly what we're doing when we're modeling a domain. Imagine you wanted to build an information system that captured all this data. That's exactly where you would start. Yeah, so if you read through this article, there's actually a bunch of different diagrams in this, and this is only a snapshot here, but you can see this is a script. This is showing me something about the the domain of interest here, which are connections between things and people in Russia and in the US and how they might be connected. But it's not an ER diagram. It's also not, it's not a class diagram, it's not an activity diagram, it's not a social network diagram either. It's some sort of other script. Yeah, and it's probably fairly ungrammatical if you look at it very analytically and you try to figure out what this formal semantics are. But it's still a script. It's still a model of the reality as constructed or as relevant to particular types of people. On the right-hand side is what my favorite article these days. It's an article about artificial intelligence in courtroom decisions and the question of whether these algorithms have bias in them or can they ever be unbiased and so forth. So when you go through this article, you can actually be a judge yourself and try to make the right decision about people that could or should not be jailed. And you can contrast that with what an algorithm would decide, and you can try to improve that algorithm. And of course, the learning from that article is that you can't get rid of the bias, neither yours nor the algorithm. So we all just have in these inherent biases. But it's very interesting because they model how the algorithm works and how you can think about making this decision, again, in a fairly different way. But it's still a script of the domain. It's still a model of what happens in the domain of making courtroom decisions. And the system, the AI algorithm that is meant to help you make the decision support system. So we have scripts, we have models of this, but they don't correspond to a traditional UML diagram. Now we can say, well, that's not of interest to us conceptual modeling researchers, or we can say, well, we gotta look at that too. We know what modeling means, we know what sort of questions are relevant, and we know how to make this better. But we're limiting ourselves if we say, well, it has to be an ER diagram, otherwise I'm not going to look at it. Yeah. Second key factor here is that the scripts, the conceptual models that we think about, they do more than just represent. They do more than just represent. They can also change, translate, and execute. That's a key difference. I mentioned earlier that the most prominent dependent variable in conceptual model research is domain understanding. That is a way to measure how good a representation is, of course. I can give you a particular diagram and ask you, well, how well does it represent the reality? Because I can measure how much you understand from that model. But if a script does more than represent, then of course we need other dependent variables. I can't measure execution goodness or efficacy or consequences by asking people how much do you understand from that domain? How much have you learned about invoice processing here? Yeah. So with script doing more than representing a reality, we need to figure out what are the best ways of measuring these different functions of a script. Yeah. Two examples here on the left-hand side that we go through in the paper. On the left-hand side, this is an example of what's called an oracle. An oracle is a digital agent that executes a blockchain contracts based on certain parameters. So in this particular case, you can bet on sports events, and you have an algorithm that then looks at what the results of a soccer game or whatever are, and if you bet it correctly, it'll pay you money. Yeah, so it really executes a digital script, automatically by an algorithm, and that of course hinges on how the algorithm models the data about the real world. Yeah, so how it models the bet, how it models the sports game, where it gets the data from, how that data is maybe quality assured or verified and so forth. And then obviously, I want the money in my bank account. So in this example, there's no human actor here. There's no analyst, there's no designer, there's no betting operator that checks the results, puts it into the system, or pays out the money. All of that happens automatically. Yeah, so they can translate here. They're translating, but not to human, only to between different digital agents. One of them might just be a sports BBC news page that gives us the updates on sports events. Another one might be the Oracle algorithm of the blockchain technology that is happening here. On the right-hand side, this is an image of a Fitbit, a wearable device that captures data about my health activities, how much I stand, how much I walk, how many calories I burn and whatnot, and probably measures my pulse as well. And it tries to affect change. It tries to make me be healthier, live healthier, be more active, be more out and about. I'm not sure about you guys, but I'm getting constant reminder that I should stand up and walk around a little bit. Yeah, so it's not just about telling me how many steps I've taken. It really wants me to do more things in the real world. So here the question of whether or not I can read the models, or whether or not I can learn a lot about my healthiness by looking at the Fitbit is completely irrelevant. The big question is whether and how it models the data, given the input that it can receive. Well, how well does it affect change? Does it actually make me a healthier person? And that depends on what data it has, how that is modeled, how the data that it could consume is then, transformed into displays of certain signs, how effective these displays are in really triggering change, not just representing it. Yeah. Third example is that we need to think about that new box that we added, which is the conceptual modeling agent. Yeah, and there are two questions here. Number one, the human agents that we traditionally thought about, they don't have to be professionals. They could be kids, they could be old people, they could be anyone. And of course, we have these digital agents, algorithms. We know they exist, and we know that they can produce and consume scripts, but we haven't really thought about them. We have no way of describing them. We have no conceptualization, no theoretical variables that allow us to distinguish them and experiment with them and so forth. Yeah. So, and two obvious examples here. The left-hand side is Atlas, the very famous robot that can do all sorts of things and do dances and jumps and flip-flops and stuff. And of course, cars that drive by themselves. So I think that's fairly obvious. And the final one is that we need to think more about the context of conceptual modeling. It is a huge difference if we're designing an enterprise system. We need to think about the data structure of an organization, or if we're redesigning a particular business process in an organization through IT, or if we think about what is the best way of supporting my 5-year-old son when he builds Lego bricks with an iPad, not a paper-based plan. Yeah. And my prime example here is if you think about what's happening in augmented reality. So in places where physical realities and digital realities meet. This is Pokemon Go. It was very popular a couple of years ago as an augmented reality game where on your iPhone you could run through the real world, and on your iPhone it would spawn all sorts of monsters, and that you can capture them and have them battle and do all sorts of things by overlaying a digital reality onto your physical reality. And if you remember that around 2016-17, it led to all sorts of weird byproducts. People were trespassing, people were running into obstacles because they were focused on their phone. But of course, it also led to a whole bunch of kids to be more active and be more outdoorsy and just be more out and about, because the only way you can win this game is that you actually have to move around a lot to find all these different Pokemons. Yeah. So I'm coming to the end here, and the main point I want to do here is to show you some main implications. So number one, we need to go back and think about designing more about conceptual modeling. We've had that focus in the early days, but we sort of shifted away from that to evaluating grammars. Well, I think we need to design more in new grammars and new scripts. We need to research new dependent variables beyond comprehension and understanding. I think I made that point a couple of times. And of course, because we now have an expanded framework where we think about change, execution, translation, different type of actors, different type of agents, different new contexts, we of course have other communities that have that focus, and we can talk more to them. Because at the heart of all digital objects and all technologies that are out there and impacting people's lives are always some scripts that specify the semantics of what that thing, that technology, that piece of software should be doing. And that is what conceptual modeling researchers are really good at understanding. Yeah. So what that means to me is that conceptual modeling is a very important topic and will continue to be a really important topic, but we need to change. So no, it's not dying. I think it's more relevant than ever, but we need to change how we think about it. Yeah. So modeling these domains and understanding how different systems model the domains in which they operate is still key to building better systems, better robots, better platform, better apps. Yeah. But we need to be more relaxed. We need to be more open and inclusive in how we think about it. How we do research and conceptual modeling needs to keep up with the times. If we continue to focus and say, this is not a model, that's not a script, that's not a grammar, none of this is our research area, then we're starving ourselves to death. So we need to be bolder, go out to the fringes of conceptual modeling and start thinking about what's with these really weird looking scripts that are not grammatical. What if we produce a model that is not even read by a single human being and is completely unreadable, but it still does stuff? Yeah? And that's really where we need to go. Only by exploring the territory of the unknown can we push the usefulness of this research field further and show others how relevant it is and how it helps them understand and prepare for a better future. Thank you very much.